All right. Hello, everybody. My name is Radek. I'm a technical director at Nozbe. And in this presentation, I will show you how we've built a truly cross-platform app sharing the vast majority of our code between not just iOS and Android, but the web as well, without using React XP or React Native Web or other solutions like it. The following is a distillation of what we've learned building Nozbe 4. Nozbe has successfully existed in the market for over 12 years now, but throughout all of its iterations, it has always been a web app. And 3 years ago, we've decided to start everything from scratch using React and React Native. But because we're still a small company, it was extremely important for us to share as much code between React Native and the web as possible, and hence this presentation. So before I continue, I want to show you a small snippet of the app, just so you have some context as to what sort of challenges we faced and overcome in our quest for code reuse. So Nozbe is essentially a to-do app for teams, right? And here we have a list of tasks randomly generated. So I want you to notice mobile-specific patterns here, like the drawer layout here. I will open one of the projects. And when I add a task, notice how above the soft keyboard, there's a bar with attributes I can assign to a task. And then when I open the task, I will see a discussion, a bunch of comments. There's reactions. I can tap on them, see what's there. And if I want to add a new comment, it will present itself in a full-screen view. So in general, this and all the menus and pickers are in this bottom card interface, which just makes a lot of sense on iOS and with some visual tweaks on Android as well. So now contrast this to the web desktop version. So as you can see, the layout is completely different. It's in columns, it's left to right, but it mostly kind of looks the same, right? But we don't have a soft keyboard, for example, so the attributes on the new task input, they're going to be on the right. And the bottom card interface also doesn't make sense. So the same pickers and menus are presented in just menus or popovers. And then we have certain capabilities we don't have on native, such as hover gestures. And when we want to add a new comment, it doesn't make sense to cover up the entire screen. It makes more sense to have the discussion in context, right? So that part is going to be different. So as you can see, mostly the same thing, the same product, the same elements styled pretty much the same way, only all the sizes are a little bit smaller. So yeah, that's kind of what Nozbe 4 looks like. And in that in mind, given those constraints, how do we fare with code reuse? Well, as of yesterday, I'm pretty proud to say we are at 83%. And that's the code that's reused between iOS, Android, and the web. And here's some more numbers if you're interested in that. So how do you do that? Well, one option is to go with one of these libraries. And especially if you're starting out and you want something that kind of many people have tried and there's more resources on it, you can go with one of these solutions. If you have an existing React Native application and you now have to port it to the web as soon as possible, go with React Native Web. There's just not much else you can do. But at least 2 years ago when we started, none of these solutions really fit our bill. It was really important for us to have a lot of flexibility, control over the abstractions, and really good performance, because there's just so much going on in the app. We need every little bit of performance we can get. So we didn't use any of that. Instead, we wanted to chart a different path where instead of trying to bring React Native to the web and kind of pretend that the web is React Native, which it is not, we wanted to go with the approach where we have a very thin abstraction layer bridging the differences between React Native and the web instead of bringing React Native to the web. All right, let's dive deep into it. So to get a shared code base, let's start with a shared repository. This is kind of how the project looks like. There's one repo, and there are 3 main chunks and 4 package JSONs. So the app folder is where all of the application JavaScript lives, and the package JSON there is for app dependencies that are shared across all platforms. The native folder is for our own Swift and Kotlin code, all of the React Native tooling, the Xcode project, et cetera, et cetera. The package JSON there also contains application dependencies that are native only, just to keep things organized. Similar with the web, it's mostly Webpack config, post CSS, auto web tooling, but also web-only app dependencies. And the root package JSON is for development tools, Babel, ESLint, Jest, etc. And just like in React Native, you have .ios.js and android.js to differentiate between those 2 platforms when necessary. We also set it up so that you can do web.js and native.js as well. So there are many tools that you have to make aware of this setup in terms of multiple package JSONs, but also in terms of custom file extensions. And I hate to say, but I can't really get into the details of how to do this because that would take the entire talk. But if things go well, we'll write it up as a blog post, as a tutorial later this year. All right, next up. What does almost any mobile app need? It needs some sort of data persistence. Many apps, they're mostly online apps using REST, GraphQL to fetch some data, so you only maybe need some caching infrastructure. Other apps have just a little bit of data, and so simple, easy approaches like serializing, persisting, MobX or Redux stores work well. But for us, that didn't work. So we created a framework called WatermelonDB, which we've open sourced and presented on this very stage a year ago. Out of curiosity, how many of you know WatermelonDB? Right, a ton of people. How many of you have tried or used WatermelonDB? Wow, there's a couple of people. That's awesome. All right. So the thing about Nose4 is it's an offline-first app. So all of your data is on the device. You have the whole copy, and it synchronizes with the server. And there is a lot of it. It's not uncommon to have tens of thousands of records. And just deserializing a JSON file at app launch doesn't work. So we need good performance. So everything needs to be lazily loaded. So we need a kind of real database. But we also wanted a framework on top of the database so that we have a reactive or observable API so that components know that they need to automatically re-render when the data changes. It also needs to have some basic understanding of the synchronization idea. And we've added, since last year, a synchronization protocol so that you can more easily hook up WatermelonDB to your own server. And of course, it needs to be multi-platform. So it can't just be SQLite for Android and iOS, because we need something abstract enough that it works on the web as well. So that didn't exist, and we created WatermelonDB, and you can check it out on GitHub. All right, next up, let's talk about styling. And this is a huge obstacle to being able to share component-level code. And you know this, but just the API for building views, texts, and styling them is completely different in DOM and completely different in React Native. And we need to solve this problem. We need something abstract enough that this difference is hidden away for us to be able to share component-level code. How do you do this? Well, there are plenty of solutions, but today I'm proud to announce that we're open sourcing a new solution to this problem on this very stage. And we call it Zacs, short for Zero Abstraction Cost Styling. And I'll just tweet about it. Twitter, tweet, sending. All right, I hope it sends. And back to the talk.
Already retweeted.
All right. So what is Zacs? Zacs is an API that abstracts away the differences between DOM and React Native for styling components. So the way it works is you define or declare components, styled components, based on predefined styles. And then you use it like a normal component and not like a raw element like div or span. So there are plenty of libraries like it. But what makes Zacs a zero abstraction cost styling is there is kind of no performance cost to this because Zacs, the library, kind of doesn't exist. It has no runtime. It's implemented entirely as a Babel plugin. And what it does is it transforms this code, this nice abstract code, to the sort of code you would have written by hand. So it just goes directly to bare metal. And it doesn't even transpile the components to components. It just transforms the call site to be as performant, as zero abstraction cost as possible. And it's both for React Native and the web. So the difference is abstracted away. So let me show you a more advanced example. Here we'll define a label, which is a text. It's going to be styled with style.label. It's going to have a conditional style that will be added if you pass a trophy value to is highlighted. And we declare that you are able to define the color style attribute by passing the prop color. And if we instantiate this component like this, Zacs will transpile it on React Native to a text with some styles, and on the web to a span with some class names, a style, and it will strip away all non-DOM attributes. So I'm kind of skimming through this. There are more features, but that's essentially Zacs. I've literally made it work in open source an hour ago. So it's now in beta. You can check it out on GitHub. But we're already using it in production, and like 99% of all of the styled components in those before are using Zacs. So there will be some more documentation and examples and flow/TypeScript types coming soon. All right, where's the catch? OK, there's a catch for now. We'll get back to it later. But the way the project evolved, we currently have two different styles for two different platforms. So unlike popular CSS and JavaScript styled components-ish libraries, Zacs is just the JavaScript part of component styling. But it doesn't tackle defining styles themselves. So what we do right now is we'll have a styles.native.js file that just exports a standard style sheet. And on the web, we'll have a CSS file. And we use post CSS in the Webpack configuration so that you can actually import styles from styles in the component, and Zacs knows what to do. But even then, though it's unfortunate, we do want to share as much of that as possible. So one thing we do is we don't use literals for colors, sizes, font styles in component styles. Instead, we predefine a palette, a standard palette of colors, sizes, widths, heights, paddings, margins, and font styles that's defined once. And then we just refer to that in our styles. And on the web, in CSS, we use CSS variable syntax, but actually post CSS compiles this down to the literal value. All right, let's talk about sharing actual component level code. But there's one more thing we have to do, and that's to define a small set of base UI components. And by that, I mean the sort of components that are entirely platform dependent and just need a completely different implementation. And it's not a long list. This is almost exhaustive for our app. But those are things like text input, image, icon for vector icons, and touchable, which on native, you have like 3 different options for styling. And on the web, it might be a button, it might be an anchor, or a div on press. So you just need to abstract that away so that you don't have to deal with those differences in kind of application code. But then, once you have those base UI components and some sort of styling, styled components library like Zacs, building actual application components with shared code is almost trivial. because now we have just enough infrastructure that you don't have to ever refer to React Native APIs directly, and you don't refer to DOM-specific things directly either. So you build components by composing together your standard base UI components, like touchable and icon, and the styled components for this particular component, using Zacs or something different. And in most cases, that's it. That's how you share the vast majority of component-level code. Of course, there will still be platform differences, and you'll have to resolve them. And there are many approaches of how to do this. The first one, the simplest one, is to just if-else it. So React Native has this platform export, and we do the same thing, except it has isWeb and isNative as well. And we made this small Babel plugin that will just eliminate dead code for platforms that are not referring to the, you're not compiling to right now. Right? And in most cases, either in in a hook, in logic, or in the render method, you'll just have some tiny difference that you'll need to abstract over, and that's all that's needed. The second approach is to build helpers. So, for example, text inputs, events for text inputs work differently on the web, where if you want to get the value of the text input from the event, you'll do event target value. And on native, you'll do event native event.text. So this is a trivial difference. You could if-else it, but it will just get annoying after 10 times. So there are many tiny differences like it. And what we do is we'll define a helper that's usually like 1 or 3 lines with index WebJS and index native.js implementations, and then use that in actual application components. The third approach is what we call platform files. So for example, in the root component, you'll probably have a lot of shared code, like contexts providers and shared logic and hooks or something like that, but also big differences, like the layout is completely different on the web and native. So what we'll do is have one index.js file with everything that's shared, and then we extract the differences into platform WebJS and platform native.js files. When there's just enough of them that it's kind of ugly to if-else it. And then you put all of the differences there. So sometimes that's a small helper component, sometimes that's a helper function or a hook, and you import that from index.js. This approach is particularly useful when you need to import something that only exists on one of the platforms, like a dependency, because you can't do it in an index.js file. It will confuse many tools, and it will break. So what we'll do is, in the platform native.js, for example, we'll import that and re-export it for the index.js file. And for the other platform, either import and re-export the equivalent from another dependency, or a placeholder that doesn't do anything, right? Like a component that renders null, or an empty helper function. So that's the third way to abstract platform differences. Unfortunately, sometimes that's not enough, and you need completely different implementations for the native, for React Native, and for the web. One reason to do it is, again, fundamental platform differences, and this is mostly the base UI components like touchable. But another reason to do this is when you want to have a completely different design. So for example, in my screencast, you've seen how all of the pickers and menus, they have the exact same content on the web and on mobile, but they're presented differently. So what we do is we have one component called model, and model index native.js implements the card interface, and model index web.js implements a popover. The third reason to have two different component implementations is to abstract over different dependencies. For example, most lists in the app are drag and droppable, and there is no one library for React Native and React that would implement that. And on React Native, we also need flat list or some sort of list virtualization, which usually you can get away without on React. right? So what we do is we have a list component with two different implementations, which is just a thin kind of API wrapper over those two different dependencies, so that the rest of the app doesn't have to care about the differences. Now, it's important to note that even when you have two different implementations, oftentimes there are some shared bits. And usually you don't want to repeat yourself and just copy and paste it into two different files, because that will get out of sync pretty quickly and will just become annoying to maintain. So whenever possible, we put the shared code in common.js that will import from the two index files. So oftentimes those are small hooks or header components with some logic. Or if there's a big component, usually you can extract, like split it into smaller components and extract some shared bits. And really, that's kind of all that's needed in our case for 85% code reuse without external libraries, with just some base infrastructure like Zacs and WatermelonDB. But I think we can do even better. I think it's possible to achieve 90+% code reuse without compromises if we had some better infrastructure in place, some more libraries. So one thing is styling, and again, I kind of cheated, didn't I? Because my 83% number didn't include the about 3,000 lines of code of styles, which is kind of repetitive code. It's not a huge deal, but it's really annoying. React Native Web has a solution to this, but it works at runtime. And what we're thinking of is extending Zacs to also tackle the styling part, so that there's a shared API for defining styles, but in such a way that it's transpiled to bare metal code, either style sheet or CSS, so that there is no abstraction cost to this. Animations, again, totally different sets of APIs. There are a lot of React libraries that work on React Native 2 for animations, but we found, last time we checked, we found that pretty much all of them are low performance because they drive the animation from JavaScript, and that's just not going to work well. You have to use the system APIs, like Web Animation API, to achieve 60 FPS. So we have kind of a partial solution to this for simple static animations, like without gestures. And what we did is we implemented a subset of React Native animated API for the web, built on top of Web Animations API to achieve the same 60 FPS as CSS animations, but with more control. And hopefully we'll open source this later this year. Next up, bundling. We use Webpack and Metro, and it's kind of annoying because both are really complex and need a lot of configuration for a big project. We hope that Whole, which is CallStack's Webpack for React Native, is the future. Last time we checked, it had some missing pieces for us, but if not today, then hopefully soon in the future, we'll be able to just have one tool to do this job for both platforms. And then there's just a lot of UI components that are complex enough that you're not going to want to implement them yourselves, like list virtualization, drag and drop, navigation, rich text editing, which generally don't really have implementations, like a shared API with implementations for the web and React Native. So we end up having to make our own wrappers and use two different dependencies for that, which is really annoying. For WYSIWYG, for rich text editing, WordPress made this Gutenberg editor, which seems great, but it's GPL licensed, so we can't use it, and neither can most of you. So that kind of sucks. And last but not least is end-to-end testing. And there are two great tools for it, Cypress for the web and Detox for native. But those are two different APIs. And for an application like ours, what you'd want in most cases is have one test definition that would actually run in the web browser and on iOS and on Android. So perhaps it's possible to abstract over those two tools to have a shared API, at least for most cases, or maybe a totally different approach, like using something like KV and building it out to be more advanced and work on all of these platforms would work. I don't know, but this is something I'd want in the future. All right, Before I leave the stage, I want to share what I think is a slightly controversial opinion with you. So, you know how back in the old days, if you wanted an app, you just wrote it, right? You want an iOS app, so you learned Objective-C and you made the iOS app. And if then you wanted an Android app, well, you have to build an Android app from scratch, right? Which is great. It has a lot of advantages, no doubt. But what if you want an app that works on iOS and Android and the web and Windows and macOS? That would be great. For an app like ours, you actually really want that. But then you have to build out and hire 5 different teams of experts from different backgrounds to implement and design 5 different apps, which are supposed to be the same app, and fix the exact same issues over and over and over again. And it's so expensive, it's so wasteful to do the same work with just different APIs and different syntax. It's really disheartening. And it's so expensive that even big companies can't do it. Is there a native macOS Twitter client or a native Slack Mac app? There's not, because it's really hard. So someone came up with this brilliant idea of just writing the code once in Java, right? It's 2003, and running it everywhere. Or 10 years later, writing everything in JavaScript and running it everywhere. And that's great. That solves all of our problems, right? No. Problem here is it really inevitably leads to bad user experience because each platform is different and unique and has different capabilities, and its users have different expectations. So to just go to the lowest common denominator, it won't get you a good product. So React Native came up with this really great mantra of learning once, writing everywhere. It's a play on words. It's kind of clever, which is cool. Like I like it. It appreciates the fact that you don't want to do the work everywhere, right? You just have to learn once the JavaScript and the React paradigm and kind of work within a similar sort of framework, but also appreciates the fact that, well, web and mobile are so different, you pretty much have to write everywhere, right? So this is cool. I like it, but I don't think that's enough. I think it's still kind of silly and really disheartening to solve the same problems, implement the same thing over and over again. Yes, of course, there are big UX differences between platforms, and they need to be respected. But at the same time, most differences between platforms, most differences between React Native and the web, certainly, are merely technical differences, like syntax differences, API differences, that we can work together to resolve. They're not fundamental to this problem. They're incidental complexity. So I want to propose a new mantra to the community, the galactic brain choice, which is to write once, learn everywhere. Not just run everywhere, but learn everywhere. So hear me out, please. The idea is that if 90% of your app, of its logic and UI and layout are the same, you should strive for 90% code reuse. Not 100% because there are differences, right? You need to make the app great on all of the platforms. But 90%, the things that are the same should be the same. You shouldn't waste time writing it multiple times. You should write once. But we're not lazy here, right? We want to make a great product. So the time we save by writing it once, we ought to reinvest in learning everywhere, in learning all of the platforms. And we really should learn HTML and CSS and UIKit and Swift and Kotlin to understand those platforms and know what users expect and tweak and polish to get as close to truly native, truly write everywhere sort of quality. All right. So write once, everything that can be written once, and learn all of the platforms to make a truly great product. Thank you.